Hi everyone, this is Kristen Hess. We're going to be using 3-column notes today to talk about the axis of symmetry. We have 2 questions we're going to seek to answer using 2 different functions, a function that's squared and a square root function. And both of them we're going to try and find the axis of symmetry. So we need to first understand what is the axis of symmetry. The axis of symmetry is the line that divides a symmetric shape into 2 congruent halves. We'll be using a graph and transformations of the parent function and tables to create the graphs and to see what the axis of symmetry is. So here I have 2 graphs. Notice that anytime you make a graph, you want to label the x and the y axis and put in some numbers so you know what your scale is. So on this first graph, I'm going to graph the function, the squared function. So when it's set up in this type of format, we can start by graphing the vertex because we know that this -5 and this -7 tell us what the vertex is. Specifically, we're going to move from the parent function. So a normal parabola is going to look something like that. And so we're going to shift the vertex to -5, -7. And this negative sign in front of the 3 is going to tell us that it's going to flip upside down. And it's going to be scaled a little bit. And so that's why we're going to make a table of points. We're going to put an x and a y here. And so we know that if we have a -5, then we get the point -7. So I'm also going to plug in a -4 for x. And when you put a -4 in for x and do the math, you're going to get a -10. And I'm going to go 1 point on the other side of the vertex to try a -6. And so when you plug in -6, you're also going to have a -10. And the reason we do this is to help us with the shape and the direction. So once we have those points, then we can draw our parabola. And we can look at it and know that because we have a parabola, we have symmetry. And right through the vertex is where our symmetry is. The left side is symmetrical to the right side. And so our vertex is through the point -5, -7. And so that means that our axis of symmetry is going to be the line x equals -5 because that's the vertex is at -5. And if you draw a line right here, then the left side would fold on top of the right side. Now let's look at this square root function. So we could start by comparing it to the square root of x, the parent function. So the parent function is going to look something like this. So there's no negative sign in front like that. So we know it didn't get flipped. So we know that what's going to happen is the starting point is going to get shifted. And the way we can find that is by looking at what's inside the square root. This needs to be bigger than or equal to 0. So 6x less than minus 12 needs to be bigger than or equal to 0. And so we'll do that math. We'll add 12 to both sides. And so we'll have 6x needs to be bigger than or equal to 12. And when we divide both sides by 6, x needs to be bigger than or equal to 2. And so that tells us that when x is 2, this whole thing is equal to 0. And so what that does is it shifts this function over to 2. And we're going to make a table of points just to help us out a little bit. So we have an x and a y. And we just found that when x is 2, we're going to have a 0. And so we'll just, if we know the shape, we can stick in one more point like 10. So 6 times 10 is 60. Minus 12 is -48. And the square root of 48 is going to be almost 7. It'll be 6.9 something. And so when x is 10, we're going to have this point here. So that helps us find the shape. It's not going to be perfect, but we do know that there's no symmetry, axis of symmetry here. We don't have a place where we can cut it in half and fold it on top of itself. So no axis of symmetry. So the key with the axis of symmetry is you need a shape where you can draw a straight line through it and it'll fold on itself. There are other forms of symmetry, but we're not going to talk about that in this video. We're going to go back to our PowerPoint. So now that we know what the axis of symmetry is, and we've talked about how to find it from the equation and the graph, and when we are going to have an axis of symmetry or not, I want you to try one on your own. So find the axis of symmetry in these two. So I encourage you to start by graphing, label your graph, and make a table of points to make sure that you're graphing everything in the correct way. Pause the video, and once you've graphed it, then come back and check your answer. So here's our answer. The axis of symmetry of the first one, the function h, is going to be through the line x equals 3. And there is no axis of symmetry for the second one because you can't fold it in half in a nice straight line. Thanks for watching, and let me know what other questions you have.